Depending on degree of activation, the needle EMG signal contains discharges of many active motor units, which can make it impossible to study an individual motor unit potential. In this example, there are two motor unit potentials that are easily distinguished by their amplitude. In a free-running EMG display, the motor unit potentials occur at different places on successive sweeps. This makes it difficult to quantitatively assess their features. The amplitude trigger allows one to time lock the motor unit potential discharges on the screen. The user defines an amplitude level, and when the signal crosses that level, the signal is shown on the screen as one sweep. The delay line allows the display of signal preceding the level crossing. Using a combination of the trigger and delay line, the entire motor unit potential is displayed. In this illustration, the amplitude level is indicated by the blue dotted line. Motor unit potential number 1 crosses it, and its waveform appears at the center of the screen. Next, motor unit potential 2 crosses the level, and it is also seen at the center of the display. Note that the potentials are seen at the same location on the display, since they occur with the same delay after actual triggering moment. All motor unit potentials that cross the level are displayed. If we raise the trigger level a little, only motor unit potential number 2 can cross it. Therefore, only the discharges of that potential appear time-locked. Now it is much easier to assess its waveform. The first motor unit potential may be seen in some sweeps along the baseline, although not in this picture. This technique requires the operator to set the amplitude level high such that only one motor unit potential can cross it. One may set this level above or below the baseline. Regardless, the method allows study of only high amplitude potentials. The window trigger allows one to selectively capture smaller amplitude potentials even when large ones are present. The user defines two amplitude levels indicated by the dotted line. Only the potential that crosses the lower level, but not the upper level, will trigger the sweep. Such signals have a peak between the two amplitude levels inside the amplitude window, and hence this is called the window trigger. In this recording we will first use an amplitude trigger and adjust its level trigger on the larger potential. We will demonstrate trigger above and below the baseline, as well as use of the rising edge or falling edge of the potential. Then we will use time window trigger to study the smaller potential.